So when we are working on exponents and of course correspondingly logs, right? Then it always is helpful to have specific examples in mind. So you can have simple example like 2 cube is equal to 8, or you can have an example of 10 square is equal to 100, right? 10 square is 10 times 10, 2 cube is. So we've done that before, but let me just write it again. So what is the cube representation, or what is the power representation? The power representation's definition is you start with the multiplication identity and you multiply it with 2 3 times. So that's what this means. 2 cube means this, 10 square means this. So if you remember one of these simple things, then it's possible to look at the connection between an exponent and a log, right? Because if you write a power b is equal to c, all of this looks like variables and head spins. So it is better to look at 2 cube is 8 because I'm comfortable with that. Yeah. So then if we give each of these a symbol, what we are saying is when you do a log of c, no? It's just a different way of writing the same expression. So log of c will be b if it is to the base of a. So let's say this is the base number. This is the result. This is the power. Okay, so these two are simply different representations of the same information, right? And just like the multiplication and division are different representations of the same information, this is also different representation of the same information. If I take log of an exponent, I'll get what is the exponent, right? So what are the rules for log, right? So log of a is what? So it means what should I raise a, maybe we should use different colors, to the power of, right, that's the b, in order to get a. What should this be? Now we know a to the power of 1 is a. So log of a to the base a is 1. Okay, so once you know that, then you can figure out all these other equations and laws that you have from here. Right? What is the first principle? This is the first principle. When I can write something like this, I can represent it also like this. So then questions like, if you have log of something plus log of something else, what happens to it, right? Such questions are there. So if you have log of c, so I have log to the base a, I have b, and then I have log to the base c. What does this mean, right? So when I add logarithms, what does it mean? So we can work each of these out through these basic principles. So, okay, the log of bc is log of b plus log of c. We will prove that later. But why is log of a power n equal to n, right? So if log of a power n, like this one, was c, then the way to write it is log of a to c is the power of a, right? The power of a is n in this case. Yeah, so if I write a power n as c, then I know log of c is n to the base a, right? There is no confusion in this, right? What is this? This is log of, this is equal to n. So that's the definition of log.